Hi, this is a lecture series covering the chapter Understanding Objects and Classes. Before I begin with the discussion on this topic, I would like to state a few facts first. If you are following this lecture along with a book, preferably the book of APC, you will find that the chapter begins with a discussion on the differences between procedural oriented programming and object oriented programming. Now, throughout my teaching life, I've seen that students generally have a problem on understanding the differences between these two because they don't have a concrete understanding of the concepts behind object-oriented programming. This is the reason why I'm going to skip the difference portion for the time being, and I'm going to cover it at the very end of this lecture series. Now, by the end of this lecture series, you will have a solid grasp on the concepts behind object-oriented programming, and therefore it would be easy for you to understand the differences between procedural-oriented programming and object-oriented programming, as the former is quite intuitive to understand, right? Now, let us begin the discussion on object-oriented programming through the help of an example. Let's take the example of inter-school quiz competition. Now, the objective in this particular example would be to identify the different or various components of a quiz competition. For example, who takes parts in this quiz competition, who hosts this quiz competition, which who are the judges, who are the participants, etc. Right? So let's move on with it. Okay. So here is a sample picture of a typical quiz competition that is held. So our objective would be to identify the various components or the various objects or entities which are a part of this quiz competition. So at the very first, we can see that we have a few students who are attending this quiz. So the student is an entity, right? Moreover, we see that students belong to different teams, and the teams are identified here using a number that's 1, 2, and 3, right? So, team would be another object or entity in the quiz competition. Moreover, also have judges, right? They are also the part of the quiz competition. Moreover, in every competition, we have separate rounds, right? So, for example, the first round, the second round, the knockout round, the elimination round, right? So, to cater about the rounds, we are going to have another object called rounds. Okay. So before we move on to list the objects, or let's better list the objects first, then we're going to move on to the conventions. So the first object that we identified was a student. The second object that we identified was the team. The third object that we identified was a judge. And the last object that we identified was the round. The order in which these objects are written does not have any significance. They have just been written in a random order. Okay. Now, the convention that I'm going to follow while writing the names of objects or the classes would be as follows. So, for the name of classes, every word in the name of a class would be capitalized. Moreover, there wouldn't be any spaces between the two or more words of a class. Secondly, the names of objects would follow the camel case convention. For example, uh, the if you want to name the object, let's say team 1, then the name of the object would be written as follows. Team, the first word would be written in all small, and then the second word onwards would have their first word capitalized, and it would look like this. There wouldn't be any space between them, and this is known as the camel case convention. See, there's a hump here. Like the capital letter represents the hump of the camel. All right. Okay. Now, our next objective would be to identify the properties of each of the objects that we identified in a quiz competition. Right. So let's move on with it. So the first object we have is of a student. Now, the objective in this particular page is to identify the various characteristics that a student might have, characteristics or properties. Now, it may be slightly difficult for you to understand what do I mean by a property, or what do I mean by uh, let me pick a good color. Let's say this. No, no, not this. Let's say this color. Okay. It might be difficult for you to grasp what do I refer to as a property. Well, if I read the first property, you would be able to identify the other properties as well. So, for example, a student may have a name, always has a name, not may. It will. They will have a name. So this would be one property, right? Now, what do you think the type of the property would be? Now, the types are valid Java data types, right? So, what do you think the type of name should be? String, right? So, if you have correctly guessed string, then you are correct. Now, let us identify a few other properties as well. For example, the student would have an age, and the type of age would be int. The student would belong to a school, right? And what do you think the preferred type for the school would be? String. Now, apart from these, they will also belong to a class. Now, because class is a keyword in Java, we cannot write the property name as class. What we can do instead is we can write std, which is shorthand for standard, which refers to class. Now, class would always be an integer, right? Next, we would have the section. Now, what do you think the appropriate data type for section would be? Well, if you guessed character, if you guessed string first, then it wouldn't be wrong. But you see, sections are always a single character, right? So the best option would be the char data type. Okay. We can have a few other properties of a student as well. But to keep our examples simple and concise, I'm going to stick with these properties, these 5 properties. All right. Let's move on to our second object. Now, the next object is a team. Now, what do you think a team consists of? What are the properties of a team? A team consists of students, right? Now, if we move on to our to our picture, we see that every team consists of 3 students, isn't it? Therefore, our team object would contain details for 3 students, all right? So under team, you would have a property, let's say student 1, and student will be of type student. Now, you might be a little confused about this type here. You see, yeah, student is not a valid Java data type, but we created a student class, right? A student class consists of these properties. Now, instead of redefining these properties for each and every student, what we can do instead is keep an object or an entity of the student object inside of the team object. Okay, well, just bear with me for a second. I guess you will understand. Okay, so it would have details of the second student, so student 2, and it is of type student because the details of students are stored in this type. And then we're going to have student 3, so going to be of type student, because every student is of student type, of a student object, right? That's the reason why we have written the student type. Now, moving on to our next object. Now, our next object is of a judge. Now, what are the different properties that a judge can have? Well, think about it. Pause this video for a second and think about it. Now, you may come up with properties that I may not write in this video, but you are not wrong. I'm going to write a set of properties, as a very concise set of properties. So if the property that you identify does not, I skip that property, don't worry, you are correct. But for the sake of this video, I may skip 1 or 2 properties, right? So pause this video right now and try to guess what properties a judge might have. So I hope you pause the video and you figure out some of the properties. So Let's see what are the properties that a judge can have. So a judge can have the name property. The judge will have a name, right? And it would be of type string. Now, the judge would have, let's say, a designation. Or not a designation. I guess designation is not. Well, a judge can have a designation. For example, a judge can have their age. I'm keeping it simple, right? And they can have their qualifications. Now, the qualifications would take up a different type. So I'm not going to go into qualifications. I'm just going to stick to name and age for the time. Let's move on to our next round. Now, inside of a round, what are the objects that a round would have? You see, in every round, we have a few teams that are playing in that round. Moreover, we would have the score, not the score, I'm really sorry. In fact, I missed a point here. For example, a team would also have a score. If you if you're careful enough to identify, you see that every team has a score, right? So the score would be maintained under every team. Code and the type would be int. I'm sorry, I skipped this part. Really sorry. Okay. Now under round, we have in the previous picture we saw that there were three teams playing in that round. So let's have the information for three teams. So team one, team two, and team three. Now, what do you think the appropriate type for these teams should be? Now, you see, a team consists of details of the students in that team along with the score that the team had obtained. Therefore, the preferred type should be team. Okay. Now, after team, we have the winner, right? The winning team. So I'm going to write here winner. This would also be of type team, because every round would has a winner. Even when there is a draw, there is always a tiebreaker that is played so as to finalize who is the winner, the runner-up and the winner, right? And every round would have a runner-up as well. So runner-up, that would also be team. And I guess that's it. Moreover, we would also have a judge, right? Who was the judge of that round? So judge, and this would be of type judge. So we were able to identify the various properties of the objects that are present inside of a quiz competition. Now, now identification of these properties help us to build this software representation of a quiz competition. So if you were ever to write a program that would help you to play a few rounds of quizzes between your friends, this is the object decomposition that you would go with so as to make your life easier while programming. All right. Now, we have identified the different properties, the various different properties of the four objects that are present in this scenario. Now, how does object-oriented programming help us to solve these issues? So, solve the problem of the quiz competition. So we have different objects. Now we have the student object, we have the team object, we have the round object, and we have the judge object. Now the data component are the properties that we had identified earlier. Data component are the properties of that object. Moreover, the functionalities, we did not identify the functionalities of these objects, but the functionalities of a student could be, for example, to answer a question. Another could be to skip a question. It could be to argue. So these are a few functionalities that a student can perform, right? So likewise, we have functionalities for team, judges, and rounds as well. But the most interesting thing to note in this particular scenario is that the objects communicate with each other to share information about themselves. So the student object would communicate with the team object so as to share the data between them. The judge would communicate with the student, and the judge would ask the questions to the student. to the teams. Moreover, every round would have uh, the information of the teams and the judges, right? So these objects communicate with each other and act as a cohesive unit to make up your quiz competition program, right? So in object-oriented programming, the emphasis is on data. It is on identifying the various different entities that are present in a particular scenario and then modeling them in software terms. So next, coming up is the features of the object-oriented programming. So like I mentioned, the object-oriented programming stresses on data items rather than on functions. But don't be swayed with this point. It does not give stress on function does not mean that we skip functions altogether. But it the object-oriented programming paradigm tries to model each software elements in terms of real-world objects. Now, real-world objects have properties and behavior. The properties are uh, let's say given to the software objects through the use of data items, and the behavior of the objects are represented through functions. So in object-oriented programming, we stress on figuring out the different various entities that are present within the system and the different data or the different properties that these objects have. Okay, this point has been explained. Then the second problem. You see, the problem of the quiz competition was a complex one. It consisted of so many different parts. But through object-oriented programming, we were able to decompose the problem into smaller units, into smaller objects which communicate with each other, right? Now, you see, in the for example, in the making of a game, let's say the game of PUBG, we have different various players, we have different objects, different items. For example, we have cars, we have bikes, we have doors that can be opened and closed. So all of these entities are modeled as objects, which can interact, and different objects can interact with other objects. For example, a player can interact with a door to open that door or to close that door. A player can interact with a gun to shoot that gun or to reload that gun, right? So decomposing a bigger problem into objects helps us to solve programs a little better and a little and in an organized fashion, right? Okay. Now, the third point, the objects can be used as a bridge to have data flow from one function to another. Now, objects interact with other objects through the use of functions. An object calls a function on another object to do something so that the other object behaves in a particular way. And this can be used to pass data between objects. The previous diagram, in this diagram, it is a conceptual diagram. It does not lay out the programming aspect of the things. This is to develop your concept regarding object-oriented programming. And later in class 10, we will understand how we are going to write the entire program that is based on this conceptual model. The conceptual model is required first, which gives us a baseline idea about how the objects interact, and then we go further to write the program which actually implements these objects, right? Now, the fourth point states that the concept of data hiding enhances security in programs. Now, what do we mean by data hiding? You see, uh, it may happen that the it used to happen in procedural oriented programming that functions which are not supposed to change a particular data used to change that data due to some faulty programming logic that was written. Now, this cannot be done in object-oriented programming model. Why? Because you see, the data of a student is restricted to student object itself. The data for team is restricted to team object itself. They can share their data if they want to, but if the functions don't exist to share the data, there is no way that this object can access the data of student. Now, why is this important? For example, there may be malicious code written inside of student objects that can update the score of team. Now, that should not be allowed, because if because a judge can only give scores to teams. The student cannot decide the score that he or she may get, right? So these security problems are handled very well in object-oriented programming through the use of data hiding. And the data hiding is inherently implemented when we implement object-oriented programming paradigm, when we write programs using object-oriented programming paradigm. Now, the fifth point is basically a reiteration of the second point. It's an emphasis on the second point. It is highly beneficial to solve complex problems because it helps us break down complex problems into manageable pieces, right? So I hope you have got a faint understanding of object-oriented programming. And in the next few lectures, we will discuss about the various aspects of object-oriented programming. For example, there are objects, classes, inheritance, data hiding, data abstraction, encapsulation, and a lot more properties. Those will be discussed in details in the upcoming lectures. So bye for now, and hope to see you in the next video. Bye bye.